Welcome. Let's start with the next system. So this one is in the casual games mechanics system, but it isn't really. We are going to be doing kind of a Flappy Bird, not a ripoff. But with this video is more about object pooling and like a level generation with a little bit of randomization. So all I did to prep for this is just found this little image on this fish. I set up a group, a game object with two game objects inside. One is the current pool, which means it's the active object, and this one is the deactivated object. And then all I did was start by putting in existing levels in here. So if I just select these, you'll see I just added some color to them, just so you could see what they look like, and just add a little bit of randomization so that when they show up, you can see the difference between the different platforms. So they all start as deactivated because if they're not active, they don't render or add to any kind of processing. The reason we use object pooling, and this is a very beginner introduction to object pooling, but it is quite a nice one because it keeps it nice, neat, and simple. So all we're going to be doing is we're going to be grabbing one of these objects and say spawn it or instant over here. So move it to this parent and turn it on. That's all we're going to be doing, and then just setting up a new position for that object. So that's what we're going to be doing. So let's first set up a quick character controller here and a little camera controller just so we can move this fish around so that we can start on the actual level generation itself. So I'm just going to go to the scripts, right click, create a new script. Let's call this, well, let's just call it fish controller. There we go. Okay, now that the script has compiled, I'm just going to drag the script onto. Okay, it almost finished compiling. I'm going to grab the script onto the fish, and we're going to keep it very basic, very simple, because this isn't really about the controller, it's the fish itself. It's more about the actual level generation. So I'm going to wait for this to set itself up. Okay, we're going to leave the, we're going to remove the start because we're going to add something else. We'll leave the update because we need it. So first things first, we need to have a serialized field. It's going to be a float, and it's going to be the speed, the forward speed, or let's call it the forward. Yeah, let's call it the forward speed. And let's just set this to something small like 0.08 f. Okay, and then we're going to need another one, which is going to be also a serialized field. Because we want to build, and it's going to be a float, and this one is going to be the actual force amount that we add to the fish, the up force. So let's call it upward force, and I'm thinking maybe 5 or 6. So let's start with 6 and see how that goes. Okay, those are my two exposed variables. Now we're going to have the public ones. So let's grab the private ones. What am I saying? So the private one is going to be the private rigid body, because we're using force, we need a rigid body, and I'm using 3D physics as opposed to 2D, so we just need to have a reference to the rigid body, standard rigid body. Okay, so let's add a few lines here. Let's type in awake, and let's add an awake function. At the start, we first obviously need to get a reference to the rigid body by going get component, rigid body, like that. And that's pretty much all we need in the awake. And in the update, we're going to be moving the character, and we're going to be forcing the character to go up. So let's start by getting the character to move. We're going to go transform.translate. Again, doing different ways. You could have done an rb.movePosition. So I'm just showing you the different ways you can move an object in the world. So we're moving from left to right. So this is going to be, we're going to be using the vector3.right. And we're going to multiply that by the forward speed. Again, you can add time.delta time when you have if you want. I'm not going to do it, but you can add it in there if you see any weird performance glitches or anything like that. So that's the forward movement. So let's put that move fish from left to right, just so it makes more sense. That's what we're doing there. Over here we're saying get the rigid body of the some game object. There we go. Okay, so after this, then we're going to go and do an if statement. So if we press the, let's try that again, if, my keyboard's eye is doing some weird stuff. So if we go input dot get, and you can choose what button you want here, mouse button down, and it's going to be 0. So if the mouse button get mouse, oh, if I spelled mouse correctly, go back there, go back there, go back there. Get mouse button down. So if the mouse button is down, we are going to say grab the rigid body dot velocity is equal to vector3 dot 0. We want to zero out any kind of velocity before we add, because remember, it's falling down. So if we add velocity but still keeping the initial velocity, the falling velocity, he's not going to jump up as much, and we're going to get inconsistent results without jumping. So the moment I click my left mouse button, I want to zero out all the velocity and then add new velocity. Or in this case, add force, and we're going up this time, so it's going to be vector3 dot up, multiply that by our up force or upward force, and then comma, we need to choose what kind of force we want to apply, and I'm going to do it as impulse. And that should be it for our character controller. So let's try this out and see what happens. Oops, I'm not quite sure which one it is because I have my example project and that was the right one. There we go. Okay, so we're going to watch it in this view to see if the character moves forward, and then if we jump up and down. Well, we'll be able to see it because the camera's not going to follow. So what am I saying? It's quite a bit, so let's make that 0.05. The reason I also multiply by time.delta is these small little values can get really out of hand really quickly. Okay, yeah, I think 0.05 is fine. Okay, so now that we have the fish moving, next step is just to grab the camera, and let's add a new script in here. Let's call it fishcam, fish camera controller. And this one's going to be very basic, and I mean, like, we're not doing anything fancy in any way. So we're going to add this to the camera root, which is just where I sometimes like to put my cameras into an object that is at the same place as the player, so that I can just move the camera around, and it's the easiest way to kind of do an artist-friendly camera where you're allowed to do the offset without having to have offset values on your script, which can get a little bit not confusing, but can get tricky if you have to keep redoing those values over and over. Okay, so we just need the update for this, so we're going to remove the start, and we only need one thing. We need to have a serialized field. Now it's going to be a transform, and this is going to be a player ref. We need to know the player's ref. We need a reference to the player. This one I'm going to just drag in the scene. That's why I'm making it serialized field. But you're probably going to want to get the player at the start, at the awake or the start, like we've done in the past. But again, because this isn't about this part of the code, I'm just bypassing all of that completely. So we're going to go and say set the camera's transform.position is equal to a new vector3. And we're only worried about the side-to-side movement. So we're going to go and say grab the player ref dot position dot x, and then we're going to go comma 0, because again, I'm not too bothered with the up and down movement, and I'm not too bothered with the back and forward movement. There shouldn't be any forward and backwards movement. Okay, let's do this. That should now have the character and the camera working, so all we need to do is move on to the actual level generation, so we can turn this into something that resembles a game. So I'm going to grab the fish and set the fish as the position. You'll see that the camera now will follow the player. There we go. That's it. There is my Flappy Bird situation. So that is good to go. So I did a little bit of setup again, like over here. I just created a manager that I'm going to add manager stuff to. This is going to control the object pooling, and then like I said, I just put my pools into a folder called pools. I have object pool and current pool. So we're going to be using all of these to get our stuff working. So the next step to do is to create a script and add it to the manager. So let's do that. Let's call it level generator. No, why not? Okay, let it recompile, and we're going to select the manager. We're going to drag the level generator and add it to the manager, and we're going to open up the script, and then we're going to start. Funny enough, the trick to this is it doesn't have a lot of lines of code, but it does so much with what it has. So we're going to leave the start, leave the update. We need those two there. We can remove just the explanations above them. What we need to do before we continue with that, we need to add our own custom functions. So we're going to go and say void, and we're going to say create platform. That's what this function is going to do. It's going to be the part that creates the platform. So now that we have all of that, let's start with creating all the variables that we need. Okay, something I haven't shown up to this point is if you put 2 square brackets, type in header, and then 2 round brackets, quotation marks, and let's just call this pools. What happens with that is that you have got a, where's my header giving me grief? Type that again. Might just be, let's just see if it continues giving me grief. My header should work. And actually, let's just remove that. We'll come back to what that meant in the first place. So let's do all our serialized fields first. So the first one is going to need a transform, and we're going to call this one object pool. What am I doing, keyboard? I'm going to duplicate this one again because this one is going to be current pool. And then the next one is going to be our offset value, our height offset value. So it's also a serialized field. It's going to be a float. We're just using the same value for up and down. So this value controls the, let's call it height offset. So this value controls where the seaweed image, like platforms that we have, how far up or how far down they can move to randomize the where they are instantiated. So it doesn't look a little bit like they're all in the middle and all you do is swim down the middle and you're okay. Okay, the next one we need, let me actually just duplicate this line, it's going to be quicker. And this one's going to be the platform distance. So this is going to be the distance the platforms are essentially from each other. So the seaweed is from each other. And then the last one again is a serialized field, and again this one's going to be a transform, and we're going to make a player ref here. We're making a reference to the player, and those are all the like accessible variables. So I'm going to hit enter twice just to give a gap between the variables so it's easier to read. The next one is going to be a private int, and this one's going to be the platform count. Now what you could do is not use this variable if you don't want to, but I just readability, it makes sense to have this. And then the next one is going to be private. It's going to be a vector 3, and this is going to be the last platform position. So this is the last platform position, and then we have one more, and then we're pretty much done with the variable set. So this one's going to be a game object, and we're going to call this next platform. So the next platform that is being instantiated. Okay, So I think we have all the variables. So at the start, again, we need to do a few things. First, at the start, we want to get the platform count. So we're going to say platform is equal to the object pool. Remember, this is the one that holds all the deactivated objects. Dot child count. So for those of you out there, if you're wondering what I'm doing, it's the same as doing a list. So whenever we're inside of Unity and you see something that's inside of something else, so like if these, let's just wait for it to compile. If I open this up, think of this as a list, and the way you tackle it is the same way that you do a list. So I'm getting all the child counts. I'm saying grab the object pool, find the amount of children that are in there, and give me that total amount of children. So that is what I'm doing at this point in the code. I'm grabbing the child count. Okay, and then we just need to, it's always safe to just set the last platform position, even if it is already 0, 0, 0 by default. I'm going to say last position is equal to vector3.0, just so I zero that out in case we have some sort of save that stores certain values. I just want to say at the beginning, please get me the object pool count and get me set the last platform position to 0, and then I'm going to call this function here. So I'm just going to copy that, put it there, and just execute that line there. So that is pretty much what we're going to do in the start. Okay, next one is another easy one because the bulk of the code comes inside of this create platform. So let's put some comments in here. No, we don't need anything at this point. It's later on that I think we should put some comments. Okay, so what are we doing inside of the update? We're going to say when are we going to be spawning a platform? At the beginning we spawn one, but after that, when do we spawn another platform? We're going to say first, I don't know why my variables don't show up inside of my if statements. Player ref dot position dot x. So I'm finding out where the player is in the x, and then I'm going to subtract the last platform position dot x, because that'll give me a float value that I can compare. So it's going to take the two vectors and give me a float value. It's basically going to give me the distance between these two values. And I'm going to say if that value is greater or equal to, and now we need to have a value of let's actually didn't create that variable, so we can make that a serialized field as well. So let's put it up here, duplicate that line. Let's call this one, let's call it spawn distance. So this is going to be the spawn distance. So the spawn distance is how close to the last platform that we just spawned does the player have to be before we spawn a new one. So spawn distance is going to be the value that we're going to use. That's where we can tweak it in the editor without having to come into the code and keep opening it up and testing, opening it up and testing. And that's it from that side. We're going to duplicate that create platform up there and put it inside of the if statement. So at the start, we create one platform. Every time the player is within range of the last platform position by this value, so if it is greater or equal to this value, then we're going to create a new platform, and then we're going to keep going round and round and round. So now comes the fun stuff. We're going to be creating platforms inside of our create platform function. So first thing again, I'm going to update my player platform count. So it's equal to object pool dot child count, and we're just going to put next to this update the platform count. Okay, so that's what we're doing. We're updating the platform count. The next one is we're going to use this variable here. Next platform is equal to, and what is it equal to? This is where we're going to be grabbing a random object from that child count. So we're going to say, go into the object pool, dot get a child. We're going to put in 2 round brackets, and in here, if you hover over get child, it tells you that it requires an integer value. So we can't say get this thing by name. It's going to be an integer value. So what are we going to do there? We're going to say random dot range. If you hover over this, I am using the correct one because it's saying that it is a It's actually using a float. Interesting. But because it's got an overload, I can put in a float or an int inside of here. It makes no difference. Okay, put two round brackets. I'm going to say a list can never be less than 0, and it can't be greater in this case than the platform count. Now we're still getting an error, so we're saying grab a random child between 0 and the amount of platforms. But remember, if you hover over this, it can't explicitly convert from a transform to a game object. This is a transform, that is a game object. So at the end of this, we need to just type in dot game object, just to be able to tell it, please grab the game object that is this transform is attached to. And all we need to do is comment this after this and say get random platform from object pool. That's all it's doing there. It's just grab a random platform from the object pool. Okay, once we have that object, we now want to remove it from the object pool and add it. Remember, we have two variables here. One is the object pool and one is the current pool. So at this point, we want to say, please set the next platform. And remember the next, dot transform dot set parent. And we're setting the parent to the current pool. So all we're going to say here is move the platform from the object pool to the current active pool. Let's call it that. That makes a little more sense. So that's what we're doing there. We're moving we're moving the platform from one object parent to another parent. And once we've done that, we need to set its position. So we're going to say, by the way, we don't want you to be kind of spawning where you are. We want to kind of have an offset so that it keeps spawning to the right. So we're going to say next platform dot transform dot position is equal to a new vector 3, because we need to build this vector up. So on the x, we want to go and grab the last platform position dot x, and we're going to add the distance. There's a distance value, platform distance. So we're going to add that amount. That is for the x movement. The y is going to be a little bit different. We're going to use a random dot range. And we're going to go between the height. The height offset, we're going to be using the height offset, so minus height offset, comma, height offset. So we're saying we're using the same value. You could create a vector too if your platforms are a little weird or they're just a little bit, like mine's symmetrical top and bottom. So that's why I'm allowed to use the same height offset. So you might want your height offset or your offset value to be a vector 2, and then make the x your minimum value and your y your maximum value, and then just feed that in directly in here. Okay, and then the last one is 0 because I do not want to move the objects in the z. Okay, so over here, let's just say give the platform a random height offset. That's all we're doing there. And then that moves us to, once we've actually moved it to the new object pool, given it a new position, we have to turn it on because it's deactivated. So all we're going to do is say next platform dot set active true. Wrong side of the. Now that it's active, so all we're going to say here, make the platform active in the game. Okay. So all we need to do now is say, remember that last position that you have? We need to update that. So we say the last position was 0, 0, 0. Now the last position is going to be equal to the next platform dot transform dot position. So we're updating that last platform position to the platform that we just built. And we're going to say update the last position to the current platform position. That's all we're doing there. Okay, so that's pretty much the logic in the code. We can test this out to see what this looks like. It's going to fire off at least. It's going to fire off a few times. and then we need to put in a kind of a fail safe, if you will. So we're going to minimize this and just kind of show you. I'm going to zoom out here so we can see our little fish. I know there should be a way to lock onto the current active object. I just keep forgetting how to do that. I will remember. So I'm just going to zoom out here so you can see what happens. We're going to start. Oh crap, sorry. My script is all good and everything, but it's not. It doesn't actually have anything assigned. So we need to assign the object pool, the current pool. We need to give it the height offset. So I think mine is 2. So I'm going to do something like 2. Let's see if that's any good. Platform distance. I think it's 6, and the spawn distance -4. I think it is. Let's just check. The fish is currently at -4.63, so I think I'm going to keep it at about -4. So it's going to move, and then when it gets greater than -4, we're going to spawn a new platform. I think that should be fine. We can tweak all of these, and then the last one is a reference to the fish itself. Okay, let's see. Now we shouldn't get any errors. There we go. This is platform number 1. Now we're going at some point we're going to run out of platforms. That's what I want you to see. Notice how they're all getting different random heights. Now we are out of platforms because now you can see that the current pool has all the objects and the object pool is empty. So we're not going to do one of those fancy object pooling where once the pool is empty we are going to we're going to instantiate some more. This game only doesn't require more than this object pool. So we're going to say only have 5 or 6 active objects in the current pool, and if you go over that limit, move it back to the object pool. So let's go back to the script to do that. So that's where we're going to go in here. So we're going to do an if statement, and we're going to say if the current, I hate it when it doesn't want to update. If the current pool dot child count is greater, and now I'm going to also create a new variable here too. So let's just duplicate that one. Let's call this, and this can be an int actually. We're just going to call this one, let's call it platform limit. So the amount of platforms that we can limit it to. So we're going to put that. So if the amount of children in the current pool is greater than the limit of platforms that we're allowed to have in the level, we are going to say, we're going to just put a comment here, return the first child in the current pool back to the object pool. Now the reason we're using the first child is because that'll be the first one that got instantiated. So again, if we go back to the level, and let's just play it through a little bit so I can show you what I'm referring to as grabbing the first child. Okay, so let's say I'm going to use 5. There we go. We're at the point where we have 5. I'm saying go into the current pool and grab the first one, which is this one that's already off camera, and move it from here to there and turn it off. That's all we're going to do. So let's go ahead and do that in the code so we can just keep recycling what we have. So in here we're going to say get the current pool dot get child. If I could spell get child, holy crap. Get child, and at 0, which is the first child, and we're going to say dot grab the game object dot set active to false. Okay, once we've done that, once it's been turned off, we're going to say get the current pool dot get child again, so I can just copy the above if I wanted to, but I'm just going to type it out again. 0 dot set parent to be the object pool. Okay, and that's it. We are pretty much done with our little level creation. So we're going to save, we're going to close, and we're going to test. And just keep an eye on it a few different locations. You're going to be looking at the level. You're going to be looking at the pools over here. So I'm just going to try to give myself some room to work with there. But first things first, I need to put a limit. So I think I'm going to only have 5 active platforms at any point. Let's see what happens. Notice once we get to 5 here, it's going to go back up into the list. There we go. Did you see how that one's disappearing? So, ooh, I can't die yet, so that's okay. Notice how we're just dragging them from the one pool back into the other pool, so we'll never run out of platforms to use. And because we're grabbing a random child, we're getting this kind of variety. So these don't all have to be the same objects. I just did it for the exercise, and all I did was change the colors to kind of show you that it is being random. We are randomly grabbing one of these children and moving them around. But what's really nice about this is, an object pooling in general instead of instantiating, is you are going to help your Unity with your garbage collection. You are going to take a little, because all of these objects already exist in the world, or if you instantiate them at the beginning of the world, you get this little initial bump, but after that you're just reusing the same stuff. So you're recycling what you have in the scene, and all you're doing is turning them on and off. And you should do this with projectiles, enemies, all sorts of things. You should have this. So wherever you can use object pooling as opposed to instantiating, I would definitely do that. And that's it. So I hope this has helped. I won't cover into the on trigger and all that stuff, and to the die. We've done that in so many videos. I don't want to spend another 5 minutes showing you guys what I've already done. You guys are smart enough to figure that stuff out for yourself. So thank you so much, and until I see you next time, be safe, and the next one's going to be the exact same thing, but doing it in Bolt. Cheers, guys.